In this video, we are going to study time series decomposition with a classical method in Python using Spyder IDE. As you can see at the bottom of the screen, this is an educational video only and no professional advice is included within it. Okay, so let's go into Spyder IDE. So the first step within the video is that we need to import the corresponding packages. Therefore, we comment this as step 1, packages. And we are going to import pandas as PD. We're importing pandas for data frames. Then we're going to import statsModels.api as SM. We're importing that feature from statsModels for data downloading. Then we're going to import statsModels.tsa.api as TS, and we're importing that feature from statsModels for time series decomposition. And last, we're going to import matplotlib.pyplot as PLT for the corresponding charts. To run these code lines, we go ahead, select them, and then we can either click the Run Selection button or we can press F9 on the keyboard. Then we continue with step number 2, which is data. For data, we're going to create an object named mData. That's model data underscore obj or object, which is equal to, and here we're using SM feature from statsModels.datasets.get underscore r dataset, and we open parentheses. First parameter, which is data name, equals to, within quotations, air passengers, comma, and at the following row we have package, equals to, and within quotations, datasets, comma, cache equals to true. So what we're doing here is the following. We're downloading air passengers data from our package datasets, and with cache equals to true means that once we download the data, it saves it locally, so we don't need to go and download it again every time we run the code. Notice that this will download data and documentation within mData underscore obj. Therefore, we're going to create a new object named mData with only the data, therefore equals to mData underscore obj, and we're going to get its .data attribute. And we want to convert this into a pandas data frame. So we overwrite mData equals to PD or pandas.data frame, and within it we have data, which is equal to mData, and we're going to select its value column, and then we're going to set its index with .set underscore index. We open parentheses, and then at the following row we have the parameter PD.date underscore range, and within it we include the following parameters, which are start equals to, within quotations, 1949, comma, end equals to, within quotations, 1961, and last, FREQ or frequency equals to M, which is monthly frequency. And last, we want to print the documentation of this data, and we do so with print, and from mData underscore obj, we're going to get its .2 underscores doc, 2 underscores attribute. So to run these code lines, we go ahead, select them, and then we're going to press F9 on the keyboard directly. And first, within the console, we can see the documentation, so we're going to scroll up. As we can see, we have air passengers R documentation, which is monthly airline passenger numbers in thousands from 1949 to 1960. And if we go into the variable explorer, we can see the two objects being created, mData with only the data, and mData underscore obj with data and documentation. So regarding the data, which is a data frame, at any of these cells, if we double click on M, we can see the data, part of this data, and specifically here, we can see the index with the corresponding date, and the value, which as mentioned previously, is the monthly airline passenger numbers in thousands. So now we're going to close this window, and we're going to continue with ranges delimiting. And we're going to create two ranges, a training range for model fitting and a testing range for model forecasting. So let's begin with the training range. So we're going to create the object named tData, which is equal to mData object, and we're going to select from the beginning of the time series all the way into the end of 1958. So 1958-12-31. So 1958, month 12, so December 31st of 1958. So here we have as the training range the first 10 years of data from 1949 to 1958. And then we're going to create F data, which is the testing range, and from M data object, in this case, we're going to select from the beginning of 1959, therefore 1959-01-01, or January 1st of 1959, all the way to the end of the time series, therefore the testing range is the last 2 years of data, 1959 and 1960. Notice that in this video, we'll only be working within the training range. So to run these code lines, we go ahead, select them, and we're going to press F9 on the keyboard. And the following step is we want to visualize the training range data within its corresponding chart. So we comment this as chart, and in this case, we'll be using PLT, which is matplotlib.plot, and within it we include T data or training range data. Then we have PLT.Y label, that's the vertical axis label, and that's going to be air passengers. Then we have PLT.X label, and that's the horizontal axis label, and that's going to be year. And the last step is we want to visualize the chart, so we do PLT.show open and close parentheses. So to run these code lines, we go ahead, select them, and then we're going to press F9 on the keyboard. And here we have the chart right here within the console. If we scroll up, we can see it. Also, if we go into the plots tab, we have the corresponding chart. So as we can see, we have air passengers on the vertical axis, year on the horizontal axis, and then the solid blue line, which is the training range data. So now that we have the data ready, we can continue with step number 3, which is time series decomposition. And in this video, we're going to study the classical method. For this, we are going to create an object which is going to be named TSDEC, which is the training range time series seasonal decomposition, therefore equals to TS, which is the feature from stats models, dot seasonal underscore decompose. And within it, we have the following parameters, which are X equals to T data or training range data, model equals to, and within quotations, additive. And at the following row, we have 2 underscore sided equals to true. So regarding the parameters, model equals to additive, that's the additive seasonal component, and 2-sided equals to true because we want to have a centered moving average. Notice that we need to check whether additive or multiplicative classical seasonal decomposition by moving averages is needed within this training range time series seasonal decomposition. Also, notice that ranges delimiting and time series decomposition function parameters were only included as educational examples, which can be modified according to your needs. And once we do this classical method time series decomposition, we want to visualize it within its corresponding chart. So we have TSDEC.plot, open and close parentheses, and PLT.show, open and close parentheses as well. So to run these code lines, we go ahead, select them, and then we press F9 on the keyboard. And right here within the console, we have the time series decomposition chart, and again, within the plots tab, we have it as well. So at the top, we have the actual data from the training range. Below, we have the trend cycle component. Below, we have the seasonal component, and at the bottom, we have the remainder component. Okay, so with this, we finish with the code file, so we can go ahead and save it. And with this, we also finish with this video. Thank you for watching.